Good. Good afternoon, sir.
Good afternoon, everyone. Please stay connected. Our guest has already joined. We'll start our program at 3 p.m. sharply.
Hello, Ajit.
Yes, sir.
Yes, sir.
Yes, sir.
Ajit, can you hear me?
Yes, sir. So we can see two screens, sir.
Hello, Ajit.
जी सर, जी सर.
I'm not able to hear you.
आवाज क्लियर आ रही है सर? Audible, sir?
I can't hear you.
So your voice is audible. Hello. So your voice is audible. Am I audible?
Hello.
Hello. वंदना मैम, आपको आवाज आ रही है?
हाँ, आ रही है. Hello. Sir, you are audible.
Hello.
Hello.
Yes, sir, you are audible
Hello.
and your screen was also visible to us. Earlier, you have seen your.
Can you hear me?
Yes, sir. We all can hear you.
Hello.
Hello. Yes, sir.
Now I can hear you. Can you
Yeah.
hear me?
Yes, sir. We all are hear you. You're audible.
I don't know. There was some problem. So, but it should be okay now. Yeah, I feel that. Yeah.
Good afternoon, sir.
Good afternoon, Getty.
Thank you, sir. Thank
Within 3 minutes, we are going to start.
No problem. No problem. It's just so now I think my screen might have been not sharing with you. It seems like that.
Yes, sir. It is not sharing
Yes.
now.
Let me try.
Earlier, it was sharing.
Yeah, I stopped it. Now it is coming.
Yes, sir. It is visible now.
Yeah, the screen is visible, correct?
Yes, sir.
Bandna, we can start now.
Okay, sir. Sure. Okay. Good afternoon to our eminent guest, Dr. Mohan Kole, sir, from University of Agder, Norway, and all the distinguished participants with great pleasure. I feel privileged to extend my warm welcome in the fourth day of FDP on application of soft computing techniques in engineering optimization. Today, the guest will be sharing with us his findings and expert opinion on the use of information and communication technologies infrastructure on optimization of energy management systems. So may I request to continue, please?
Good. Thank you, Vandana.
Yes.
Thank you very
Thank
much
you,
for
sir.
giving my introduction. And if you are not able to hear me, just raise your hands and tell me, okay?
Sure, sir.
So today's lecture is going to be in continuation to my yesterday's lecture. And today I'm going to share with you the experience of one of my European Union project. And that European Union project, it was basically focused on how we can utilize information and communication technologies infrastructure for intelligent home energy management system. And it is going to have more like a centralized approach. And we know that we are talking about the smart grid, and most of the smartness is going to come from the distributed network. And when we want to have the smart cities or smart electricity network, especially within the distributed network, then we have to identify some key areas or key topics on which we can give some contribution related to the smartness into the system. So in this project, the smartness has been identified, like how we can utilize the information communication technology infrastructure for shifting the operation of non-critical power intensive load in such a way that it should not compromise the user comfort and behavior, and how we can do that in a centralized way. So that is the key objective behind this project or behind today's lecture also. So here you can see that we are talking about the demand side management. It looks like it is a more electrical engineering topic, but it is not. It needs to have more integration from different disciplines so that we can achieve the intelligent and the smart operation of non-critical power intensive load by reducing the peak demand within the distributed network, as well as considering the grid constraints and the renewable energy production. So with reference to this point, then I will go to the second slide. In the second slide, already I have shown this slide to all of you in yesterday's lecture. The first project, that was electric usage in smart village scarpness building integrated photovoltaic system, that we discussed yesterday. And today we are going to discuss about scalable energy management infrastructure for aggregation of households, which is funded through competitive process from the European Union under the 7th Framework Program. And also I briefed you some of the concepts or some of the technologies which we are developing under the TERI and UIA project under the theme of sustainability and clean energy, especially for the focus on smart microgrid architecture for promotion of solar photovoltaic system. That was one point. Second point, it was recycling of solar photovoltaic modules also, and third, it was biomass based gasifier and its application through ORC engine or organic Rankine cycle engine for production of electricity and heat. Okay, so in today's lecture I will focus on the second project, that is a scalable energy management infrastructure for aggregation of households. Now, this project, it is under the category of information communication technology, and it was under the call of FP7 ICT 2013 and 11. And this project, it was for how we can demonstrate the research technology development using ICT infrastructure for a particular case. So in this project, we proposed that we want to utilize information communication technology using the virtual power plant approach for shifting the operation of non-critical power intensive load in the domestic applications, and such type of system, how it can help in reducing the peak demand on the network. At the same time, how this system can incorporate the prediction of intermittent renewable energy sources, as well as the prediction of the load demand. Based on that, how the virtual power plant can generate the demand side management scenarios centralized, and how those scenarios can be communicated from the virtual power plant to the home energy system or home energy management system for shifting the operation of non-critical power intensive load. Okay, so I believe that you are getting the idea that how the ICT infrastructures are going to be utilized with computing techniques for the demand side management within the distributed network and especially within the home energy management system. So this project proposal have been submitted to the European Union, and under this call FP7 ICT 2013-11, there were 60 applications. Out of 60 applications, 5 applications or the 5 proposals, they have been shortlisted. And among 5, this proposal was there. Then we had the discussion with the European Union and the presentation also. And out of 5, then 4 projects have been funded by the European Union. And my role in this project, it was as a technical manager. Okay. So I'm quite confident to share the technical knowledge or the technical learning from this project with all of you. Okay. This project, it was for the period of March 2014 to May 2017. So approximately 3 years and 5 months or 4 months, let's say. And the project funding which we received for this is quite high. It was around 3.8 million euro, so which is a very big funding. And the scheme for this project, it was that how we can utilize information communication technology for a low carbon economy. So that was the scheme theme. So to justify that ICT for a low carbon economy, right, especially within the smart energy grids. So we developed this proposal considering how we can make home energy management system which can get the information from the backend or from the virtual power plant in the intelligent way, right, and help in shifting the operation of the selected load. Okay, and the target outcome of this project, it was how we can provide a scalable ICT infrastructure to control electricity consumption from household appliances as an incentive-based demand response program. Okay, so it means that how we can use this ICT infrastructure scalable, okay, for controlling the electricity consumption or maybe shifting the electricity consumption of selected household appliances. Okay, but how we have to do? We have to use some incentive-based demand response program. So this incentive-based demand response program is going to come, okay, from the backend server or from the virtual power plant, and this virtual power plant is going to provide the demand side management scenario to a particular group of houses or to a particular distributed network, okay, so that it at a particular time the demand within the distributed network is reducing. Okay, so and then at the same time we are also considering the user behavior. And another very good point is that we are not touching the operation of critical power intensive load. It means that all critical loads are effectively operating as it is required, but only the non-critical load which need to be shifted only. So it means that we are again considering the user behavior, user preferences also, but how we are considering that? Using the information communication technology infrastructure. So this project has been very interesting. And here you can see that within this 3 years, let's say 3 to 4 months period, how we have to achieve these objectives of the project, okay, and at what technology readiness level we want to provide the output from this project. That is again very important. So from here, from your point of view, because most of you are quite young faculty and you need to develop yourself. So while developing yourself or creating your or future academic career or improving your knowledge, so I believe that today's lecture may help you in understanding how we have to integrate different technologies together for achieving the key objective of demand side management. Okay, so now I'm going to next slide here. Sorry. Now you can see my slide now.
Yes, sir.
Yeah, very good. Yeah. So this, as many of you may be knowing that whenever we want to make any project proposal application to the European Union under the competitive grant scheme, at least we need the partners from 3 European countries. Okay. So here we selected the partners from 4 European countries: Norway, Denmark, Switzerland, and Germany. From Norway, my university, University of Agder Energy Net, and Agri Consulting, they were the partner. From Switzerland, HSSO, Net Plus, Misorio, SEIC, they were the partner, and CSEM also, they were the partners from the Switzerland. And from Denmark, Aarhus University and Devolco Products, they were the partner. And from Germany, the leading research organization, Fraunhofer, they have been the participant in this project. Now here, out of 12 partners, you can see that there are only 3 universities: Aarhus University, University of Agder, and HSSO from Switzerland. And remaining are either industries or the research organization. So Fraunhofer, it is one of the leading research organization in renewable energy technologies, especially from the Germany. And Devolco Products, it was from the Denmark. And it is quite good in manufacturing or supplying the IoT-based devices for the smart management system, including energy management system. Okay, and Agri Consultancy, it is a more like a software testing organization which help us in testing of the softwares which we have developed in this project. CSEM is again the research organization from the Fraunhofer. They were in a position to do some technical analysis of how the distributed network demand side management and the solar photovoltaic system can impact the operation of a distributed network. Okay, and then if we come to the Net Plus, so Net Plus, it was the Switzerland distributed network company. Okay, just like our Madhya Pradesh Electricity Board, but at the same time, this Net Plus is having the facility or is having the operation of mobile also. So they are also involved in the as a mobile operator. So that was again one great advantage, because mobile operation or let's say communication operation as well as the electrical infrastructure both have been owned by the same company. So it was quite good to utilize their infrastructure within this project when we are going to use ICT system for shifting the demand side management. Then here another company, that was Agder Energy Net. It is the South Norway company, which is again the utility company or the distributed network company, but it has again generation, distribution and transmission all combined with the Agadir Energy, but we involved only the distribution side. And then NLPN from Switzerland, it was there. Again, that NLPN is also involved with the distributed network. And then one more company here, you can see that was the Misorio. Misorio is one business company in Switzerland. They were involved in developing the business models, especially for the energy system. And Aarhus University, it was the coordinator of the project, and they used their information communication technology division in this project. And my university, University of Agadir here, we contributed on security and privacy of the ICT infrastructure, as well as developing the algorithms for the demand side management here. Then you might have seen that HESSO from Switzerland was there. HESSO Switzerland, that is a Swiss university. So they contributed on how we have to integrate the front end and the back end infrastructure together, and how the installation of the different smart intelligent devices or the products which have been provided into this project by Developco products, how they can be integrated within the houses, and how they can get the information from the centralized server. Then coming back to the Fraunhofer. Fraunhofer, they have the very good facilities or the capability of the virtual power plant, as well as they developed their own platform, Ogema platform, that we used into the home energy management gateway. So here you can see that, so how the different expertise of different organizations have been integrated together for this project, and then utilizing their expertise, okay, then how we have to justify or how we have to distribute the works among the partners for achieving the key objectives of the project. So here you can see that when we want to do the project, multidiscipline project, multi-partner project, considering the key objectives of the project, we have to identify which partners should be there, how we can utilize their expertise, and how we can work together. Okay, so that is really a very good point here from the learning point of view also. So let's say if you want to develop a proposal on a particular topic, of course it will be not only by one organization or not only by one particular small group of people, but that project is going to be multidisciplinary and incorporating multiple organizations from the multiple locations also. Then of course, after identifying the key objectives of your proposals, we have to identify the key partners. Then accordingly, we have to define or refine the objectives and see that how we can develop the work packages for achieving the key objectives, and how we can incorporate the expertise from the different organizations. So here, this is the learning from this slide, I can say. So now, coming back to the key point of, so new slides came now?
No, sir. Your slide is now scalable energy management infrastructure for aggregation of households.
So first slide only, right?
Yes, sir.
Right.
Right, then I think I will stop sharing and then again I will share it. Then let's see. So you were not able to see the partner's screen or like that?
Yes, sir.
Yeah,
We
just
have seen only the first slide that you have shown.
only first.
Yes, sir.
Give me 1 minute, okay? I'm just changing
Yeah,
my
sure.
system. Now
So,
you can see.
So scalable
Earlier,
energy management.
earlier slide had.
So it is showing project number 619560.
Yes, sir.
Okay.
Yes.
Now I came to the next slide. So here you can see the European Union logo and the logos of all partners. Correct?
Yes, sir. Yes, sir.
Okay.
It is displaying.
So, yeah. So I was on this slide now. Okay. So when I was explaining you the contribution from different partners. Okay. So I was on this slide. Okay. So are you able to follow this slide now?
Yes,
After my
sir.
explanation? Okay. Now we will move to the next slide. The next slide is SEMIA and Smart Grid Challenge.
Yes.
Is it okay?
Yes, sir.
Yeah, very good. So here you can see that there are two domains have been taken maybe. One domain is, let's say, the cloud-based domain, and another domain is the customer domain. In the customer domain, in this project, the target was that how we can shift the operation of non-critical power intensive load. It means that how this customer domain can provide the flexibility, okay, and, to reduce the peak demand, and then we have the flexibility, or we have to use the flexibility from the grid or from the cloud also. So from the grid side or from the cloud side, we used in this project virtual power plant approach that we called as a backend system, and customer domain that we called as a front-end system. So from the backend system, from where we have the grid and market both, okay, we are getting the information, what the price signals are there, how the incentives and tariffs are going to be there, okay, and how this grid or the virtual power plant going to provide the control signals to the customer domain, what flexibility it can be offered, okay, and then of course we have to consider the bidirectional information exchange, okay, how we can do the forecasting, how we can utilize the information of the demand forecasting, renewable energy predictions, etc. And those information, then they are going to go through the smart energy meters. So here you can see that in this project, the grid or from the cloud, the demand side management scenarios have been communicated to the home energy management gateway or within the customer domain for providing the flexibility. Now, this is the more like an overview of the project. Now coming back to the key objective. So till this point, you got the overview that how the expertise of different partners we have to integrate together in achieving the key objective of demand side management. Okay, so I hope that you are in a position to see this project objectives slide.
Yes, sir. It is visible.
So now on the project partner slide, I tried to explain you the expertise of different partners. Based on the expertise of different partners and the key objective of this project, the overall objectives have been divided into the 7 categories. First objective, it was that how we can make technical and functional design, right, using front-end system and the back-end system. Okay, so that is very interesting. Second objective is that how we can utilize the information communication technology infrastructure, okay, for this purpose. Then third objective, which is a very interesting objective, how we can make or how we can use aggregation intelligence for deciding the demand side management scenario. So here in aggregation intelligence, we have to consider that how the demand consumption is going to be there in the home, in the selected homes. Then, so we have to take that aggregation into account. Similarly, we have to take into account the aggregation of the renewable energy production also. So that have been covered into the objective 3. And then based on that development of aggregated intelligence, we need to work on developing algorithms or the control signals for home energy management system. So for that, either we can use centralized approach or maybe decentralized approach. But in this project, centralized approach have been used. I will explain you that how that centralized approach is going to be working there. Then next objective, it was that integration of front end and the back end system. Here in this project, the front end, it was described as home energy management gateway, and the back end, it was described as virtual power plant. Okay, so the objective here is that the back end is located in the cloud, okay, as a virtual power plant, but the front end is located within the selected houses. Okay, so how we have to integrate them, which technology we need to utilize for integration of front end and back end, how they are going to communicate with each other. So that have been very interesting and challenging also. Now, when we are talking about this home energy management system, and in this project, the requirement from the European Union, it was that the technology readiness level should be around 5 or 6. It means that whatever the work which we are going to do in this project should be readily available for the market implementation or to take off this technology into the market. So when we are talking about this level of the technology, it means that we are not going to utilize the academic research or the lab-based research, but we need to demonstrate this within the society. So then here objective 5 is pilot testing and validation. During the consultation phase with the European Union, before the finalization or the approval of the proposal, it had been advised that we need to demonstrate this system in a very high number of houses in 2 different climatic zones or the regions. Then we selected 100 houses in Norway and 100 houses in Switzerland to demonstrate this system. So that has been a very interesting and very important point, and which have been covered into the objective 5. It means that whatever the technology we are talking for the home energy management gateway, considering the virtual power plant or the backend system, that we need to demonstrate in the real operational scenario. So it means we have to do the pilot system. So that pilot system have been done and within 100 houses in Norway and 100 houses in Switzerland. So that have been covered into the objective 5. Then coming back to another very important point. What is that? That is the security and privacy. When we are talking about intelligent computing techniques, optimization things, so the key thing is that when we are using different computing techniques, communication technologies and like that, so we have to consider security and privacy. We know that in today's digital world, if our system is not completely secure and not considering the privacy, so someone can hack it and play around it and do some wrong things. So it means that whenever we are trying to use our knowledge for developing smart energy system or the smart network, so then of course we are going to utilize information communication technology infrastructure. So then we have to consider very seriously about the security and privacy. That should be on top priority. Okay, so in this project we have one key objective, that was security and privacy. So my university, University of Agadar, they were leading this work package on the security and privacy also. So now here you have seen that we consider operational things, okay, and aggregation intelligence also, ICT infrastructure also, pilot testing also, we consider about the security and privacy also, and overall we are trying to demonstrate, or overall we are trying to understand that how this home energy management system is going to work in real condition with in two different climatic zones. Okay, so it means that such type of system are going to impact the businesses of the distribution company. Okay, so then of course this utility company or the distribution company, they have to come with the new business models. With this new business models, they have to consider that how they are going to provide the incentives to the users, one point. Second point, not only providing the incentives to the user, but also the utility company has to see that how they can make the revenue or the income out of this. Okay, so no one is going to do anything free. So everyone want to have some earning in one or in another way. So here, that's why we have one key objective 7, that was how new business models can be developed for the scalable energy management infrastructure for aggregation of households. So through these slides or through these objectives which have been described on this slide, you are in a position to understand that in the field, or when we want to do the research technology demonstration with pilots, then how we have to incorporate or how we have to integrate the industry contributions as well as the domain knowledge from different disciplines together. So here you can see that this project, it looks like more on the electrical energy management side, but here you can see that most of the importance or most of the players, right, they are from the ICT side also. Okay, then of course we are also talking about the products deployment also, product development also. So of course we need some hardware engineers also, and then of course we are also talking about the business model. So we need the persons who are going to have good understanding of the energy business. So from this slide you can learn, right, whenever we have to develop any project, right, how we have to integrate information communication technology infrastructure, okay, how this computing techniques they are going to help, okay, and how we can utilize the expertise from different domains together for achieving the key objectives. Is it okay? Are
Yes,
you
sir.
able to?
Yes, sir. Yes, sir. Yes, sir.
Yeah. So now coming back to the SEMIA system, in the previous slide, I have shown you the key objectives. Okay, so those key objectives, if I have to explain in a simple way, okay, so this slide will help you. Here on the front end system, we have the home energy management gateway. And on the backend system, we have the virtual power plant. Okay. On the front end side, when I'm talking about the home energy management gateway, in this project, the home energy management gateway, it was the size of our mobile. Okay. And this device, it was having the operating platform, that's what we call it, OGEMA. And this operating platform OGEMA, okay, in the home energy management gateway, it used to get the information from the backend, that is the virtual power plant, using 3G communication technologies. So here you can see, now we are using 3G technology here. So for that, then we need mobile operator. So we have the NetPlus there. So the NetPlus company, they have provided that facilities also. So here you can see that how we are utilizing the infrastructure or the facilities which are available from the different partners. Okay. So from the virtual power plant, the demand response scenarios or demand incentive scenarios, which have been communicated to the front end. Okay. On the front end, we have the home energy management gateway, which is the size of our mobile. Okay. How that information is coming? That information is coming through the 3G. And then when that information is coming to the home energy management gateway, then this gateway has to send the information to the selected non-critical power intensive load of which we want to shift the operation. Then this home energy management gateway, which was the size of our mobile, right, it was communicating to the selected appliances through Zigbee communication. Okay. Now here you can see we are using now within the home the Zigbee communication for shifting the operation or controlling the operation of selected non-critical power intensive load. Then at the same time, here on the front end side, you might have seen that there some of the houses, they may have the building integrated photovoltaic system. So they may be producing the renewable energy there also. And in yesterday's lecture, I have shared that with you also. So then here you can see that this home energy management gateway is very important, okay, to communicate or to get the information from the backend and communicate that information to the selected non-critical power intensive load for shifting the operation, considering the local grid constraints also, and at the same time considering the user behavior or user preferences also. So on the front end side, you can see that in this project we are involving the society also. So it means that society is also having their effective contribution in analyzing the results from this project. So it means that the society, right, or the people who are using the home energy management system, they may not be technically qualified, okay, but they are the users, okay, and we have to respect their preferences also. We have to respect their comforts also. So how the user preference, their comfort have been considered in the home energy management gateway, that is again very important point here. Then coming back to the backend, on the backend we have virtual power plant, and in this backend the virtual power plant facility, it was from the Fraunhofer, Germany, and you can see that the virtual power plant, it had been located in the Germany, but the pilots were located in Norway and Switzerland. So with the help of the ICT infrastructure, or with the help of intelligent computing techniques and information communication technology, we are utilizing the resources or the available expertise or the technology from one location to another location. So here you can see that how this European Union Framework 7 project or integrating the contribution from different European countries together. So here on the back end, we have the virtual power plant, which is located into the Germany, and on the front end side, home energy management gateways, they were located in 100 houses in Norway and 100 houses in Switzerland also. Now, another very interesting point, when we have this, let's say we'll take the case of the Norway. Okay, so in Norway, based on the demand consumption, there is going to be, we need to consider the aggregation of the demand based on that, the prediction also, and also within that area, how the renewable energy production is there, considering the grid constraints and like that. So that information is going to be used by the backend system, which is located at the Germany, right? And from that, from the Germany, or from Germany, Fraunhofer, the virtual power plant is sending the demand side scenarios through 3G to the front end system, which is located into the Norway. And then based on that, then considering the user preference, this home energy management gateway, okay, is shifting the operation of non-critical power intensive load. So here this home energy management gateway, it was manufactured and provided by Devolco product from Denmark. Okay, so that product we used in this project. And similarly, they also provided the Zigbee communication system also with the power plug and all other remaining small things which are required for giving or for showing the demonstration of such type of system. So here you can see that if the right side curve, it looks like a very simple curve because we are trying to shift the peak operation and we want to make the curve very flat. But to achieve that, okay, because I know that many of you are electrical engineers and are teaching basic electrical engineering or maybe power generation and distribution also, and you may be using this curve for explaining plant load factor, utilization factor, capacity factor, and so on and so forth. It looks like a very simple to explain that, but to achieve that, here you can see that how we have to integrate different technologies together, considering the information communication technologies, or how we can use the computing approach. Then on the front end side, you might have seen that there is one mobile is also displayed there. So in this project, the plan was that to develop one application or the app for our mobile system, so that through that app, we should be in a position to see that how we are getting the information from the virtual power plant, how the loads are shifted there, how much energy savings, not the energy saving, but how the peak demand has been reduced, how the load curve is going to be there, and whether you and the users can also see that which load has been shifted, and so on and so forth. So are you able to understand here?
Yes, sir.
Very good. So now here you can see, right? So all these things have been integrated into this project. And then when we are talking about ICT infrastructure, now you have seen that 3G communication is there, Zigbee communication is there, and collecting the data and sending those data to the virtual power plant or the backend, right? So all this data we need to have, we need to consider from the security point of view. So in this project, then you might have seen that here in the upper layer, security and privacy management was there also. And then, of course, when we have such type of system, so such type of system is going to impact the businesses of the utility company also, and other companies which are also involved in that one, and at the same time the user also. So we need to consider that how this system is going to impact the businesses and how the learning from this project can be incorporated in developing new business models. So here you can see that within this project, how the different objectives have been identified and achieved. Okay. So now I will go to the next slide here. And here you can see that we're talking about the demand response system. And in this project, the centralized approach have been used. And in the centralized approach, we are getting the information from the backend system, that is the aggregator or maybe the virtual power plant, to the front end system, that is the home energy management gateway. So basically, we are using wide area network here. Okay. Then another very key point is that I also explained in the key objective that how we have to do the front end and back end system integration. So that have been very key point here. So for that, we used the expertise of HESSO Swiss University. So they were quite good in that. Then coming back to the front end system, here we have the home energy management gateway. We have a lot of sensors, actuators, smart meters, etc. Okay, so those all products basically which we need here, right? So in this project, they have been provided by the Devolco products. So front end system, we are considering about the customer. So customer here, basically we are trying to do the load profile management, monitoring, okay, then also at the same time collecting the information from the front end system and providing that to the back end system, because we are going to do the aggregation at the backend system. And then on the front end system, what I mentioned that in the previous slides also, the mobile application can also help us to analyze or to get the understanding, right, what type of data we are providing to the backend system, okay, how our load profile is there, okay, and how the overall operation is happening. Okay, so that is on the front end side system, we have the customer, and then now we come to the backend system. Backend here again, very important point. Front end system, it was located into the Norway and Switzerland, and backend system, it was located at the Germany. So front end system is providing the information or the data to the backend system, and then backend system is doing the aggregation and doing the analysis of the demand forecasting also, as well as considering the renewable energy prediction also. Based on that, and considering the grid constraints also, and considering the limits of the conventional power plant, then this backend system is going to schedule the demand side management scenario for the load control. Okay, so then it created some scenario for scheduling of the loads. Then it comes like which appliances has to be selected for from the selected houses. Okay, so here I mentioned that it is a centralized approach. So it means that the backend system, it knows that which type of loads are shifted there. If it might have been decentralized, then backend system might have been not able to know. Okay, and of course, when we have such type of system, we know all of us, we know that always there may be some going to be some scenarios like where the system may not work and like that. So we have to consider that alarm and event handling also. And of course, then here the data collection from front end side and on the back end system also, it need to be there, and how those data can be used by DSO or the TSO, means distributed system operator or transmission system operator, for the energy management system, or for the user management, means like to considering the fluctuations of renewables, how it can help us in reducing or managing the household demand also, and the grid constraints also. And then when we have all this data and like that, so we don't want to utilize only for the running this project, but also for the future analysis or doing some statistical calculations and statistical decision analysis also. Then basically on the backend side, okay, so we are using web as a service or software as an agent. So here you can see that how this project is going to help you in understanding the key theme of your faculty development program. This faculty development program has a key theme on soft computing, okay, intelligent techniques, optimization. So, and of course for that we need ICT infrastructure. So how these all keywords or the key topics of your faculty development program have been considered in this project. So this, the learning from this project or the information which you are going to get from this project is going to be very useful for you to get the overview, right? How we can utilize soft computing techniques, intelligent controllers, sensors and actuators for optimization of smart energy systems. Okay, so here my objective is not, because all of you are working professionals and already you have all basic understanding, right? So now you need to have more high level knowledge. Okay, so that high level knowledge will help you, right, in understanding or refining your teaching also, or refining your previous learning, so that you can utilize that your previous learning in the multidiscipline way, okay, and to contribute towards the society. Is it okay?
Yes, sir, definitely.
Very
Definitely we'll implement in our
yeah,
life.
because I want to have some communication from your side also, because sometimes we know in this ICT system, sometimes we may lose the connections
Yes,
also, and
yes.
like that. Yeah, very good. Otherwise, I might be speaking and you people will not be listening, so that's not good again. Yeah, okay. Good. Now here, this I explained on the previous slides, front end and back end system. So here, this front end and back end integration have been explained in a very systematic or technical way. Okay, those who may be having some background on computer engineering also, or maybe information technology also, they may be in a position to understand the connections between the front end and back end here. Front end is in the yellow and the back end is in the light blue color. On the back end, we have the semi-intelligence, and on the front end, we have the home energy management gateway. And on the front end, home energy management gateway is considering the OGEMA platform. Okay, and here you can see that how the different sensors, actuators, and like that, they are getting the information, and how the front end server is there, and how the backend server is collecting all this information, and how distributed system operator as well as transmission system operator, they are coordinating with each other. Okay, it means that how we are getting the integration of the front end and the back end, how we have to do the flexibility forecast, based on that how we have to do day ahead scheduling, then how we have to do the aggregations and so on and so forth. Because now here you can see that we are collecting all the data of the home energy or the home energy consumption, let's say, based on selected appliances also. Then you can use your computing technique, different computing techniques for doing the forecasting analysis also, because I know that Krishna Tirath Chaturvedi is quite good in soft computing, right? So he can use some of his technology or some of his knowledge or the learning in this, in such type of project also, like that. For example, let's say we want to do the load prediction. Okay, so we can use maybe, for example, stochastic modeling also, or maybe we can use artificial neural network also, or maybe we can use many different methods are there. But at the same time, we have to see that how we have to see that how other different parameters they are also impacting. So it means that during this forecasting, we have to consider that how different external parameters they are also impacting, or how they can be considered for forecasting the load demand also. That is one point. Similarly for the renewable energy also. So some of you might have referred some of my articles in which I have included, while doing the demand prediction or the renewable energy production for the urban area, or even for the single households also, how the different external parameters they also impact. For example, the weather parameters, user behavior, or housing conditions, and like that, right? So here you can see that how we are integrating different soft computing techniques for demand side management. Okay, so I will not go in much more detail now because we are running out of the time. So, and our objective in my objective is not that to give you so very micro level information, but to provide you more at the high level information, and so that you can develop yourself or making some new projects. Or then we are coming the project implementation point of view. Flexibility forecast service, it has been used by the front upper, of the front upper as a generic virtual power plant. And design and implementation of grid constants for distributed system operator, right? So we consider the feeder till the feeder and household levels also. And then different type of security and privacy layers have been tested in this system also, and different protocols also have been developed and tested also. And on the home energy management gateway, that was from the Develco product, OGMA platform have been used, that was from the front upper also. Then there's different hardware or the components. Sensors, they also need to be integrated at the end customer level. They were provided by the Develco products in this project also. And then of course we need some hardware for monitoring the temperature, monitoring the operation of selected non-critical power intensive load. And I missed to mention you that in this project we selected the boiler as the main load to shift the operation, because you know that in all cold climate countries every house is having the boiler, and due to thermal inertia it can be a non-critical load and it can effectively contribute onto the demand side management. But in other project or in extension to this project, we also selected the electric vehicle, washing machine and dishwasher, cloth dryer, such type of things also, which can basically as a non-critical power intensive load. And then by defining the user preference, we also consider that more as a decentralized approach in the demand side management. But for that also we need to get the information from the centralized server or from the backend system or maybe from the utility, that at what a particular time how much demand should be there, so that we considered into the decentralized approach work. But in this project we used centralized approach. Okay. Then this integration of the front end and back end, it was through with message oriented middleware, which was developed especially for this project by HESSO. And then implementation of provisioning concept based on telecommunication system means basically we need to use 3G communication, that was from the Net Plus also. And flexibility forecast, so here we used stochastic methods for forecasting, so that have been used, that have been integrated within the virtual power plant of the front upper. And then the scheduling, means the demand side scheduling have been provided by virtual power plant from front upper to the home energy management gateway. Then another thing which is a very important thing is algorithm, right? So I was a key responsible person for developing the senior intelligence algorithm or the scheduler. Okay, and that deliverable D5.1, which we call it, it was recognized as one of the best deliverables from the European Union, and that deliverable, it was the heart of this project, because in that deliverable we developed or we provided very intelligent algorithm for shifting the operation of non-critical power intensive load, considering the user preference and the user behavior with two approaches, one centralized and decentralized. Okay, and of course then when we are considering this scheduling algorithm, then we have to consider the grid constants also, that is very important. And I mentioned that security and privacy, it is really important, so that have been considered throughout the project. Okay, how this type of system can be used or can be considered from the hacking point of view also, or if suppose there is some security loopholes, then how this system can be behave, or will be in a position to shift the operation of some the selected loads also, like that. Okay, then we did this testing configuration analysis. That's what we call it beta testing, right? That one was from the Agri Consulting or Devo team. And then of course the business models, which was basically from the we used from the Swiss company MIS Energy on platform, right? So how the flexibility trading can be incorporated into the energy business models. So main technical results. So this project have been installed in 100 houses in Norway and 100 houses in Switzerland also, and they have been tested for different scenarios also. Different security layers have been installed and tested with different protocols also. And then automated demand response only for the heating system was carried out in the Swiss part of the boiler of the pilot. And now here you can see that all the partners, they have effectively contributed in achieving or successfully completing this project within the period of 3 years 4 months. Okay, initially this project, it was for the 3 years, but we got the extension. We got the extension for 3 months. Okay. So are you able to understand?
Yes, sir. Definitely.
So now I'm stopping here, and now I'm requesting to have some participation from the, or some questions or discussion from the participants.
Sure, sir. I would like to request from the participants to ask their queries. Feel free to ask. You can unmute yourself, or you can ask through chat.
Yes. So maybe I think Vandana, you can coordinate with the participants, or maybe Katie, you can coordinate, or Ajit can coordinate, and then we can have some small discussion.
Definitely, sir.
Sure.
I'm just seeing the chat box. Any questions? Participants are requested to ask queries through chat box, or you can unmute yourself.
Yeah, and even they can switch on
Yeah,
their
you
video
feel
also now. No
free or
problem.
comfortable to ask.
So we can see that who is there, who is asking the question. Yeah.
Yes, Nitish Chopra sir is trying to ask a question. Yes, sir, you may ask. Nitish sir.
Hello.
Yes, ma'am. You may ask. You are audible. Hello, Paramjeet ma'am. You are audible.
Please unmute yourself.
Okay, now I am audible.
Yes, ma'am.
Yes.
Okay. Good afternoon, sir.
Yes, please go ahead.
Sir, in grid connected, sir, in isolated mode, not in grid connected mode, in isolated mode of with the help of grid connections, or with the help of main grid, system is always in reliable mode, but in isolated mode there is some issues. So how we can increase it? Can we use the energy management system again here?
Yes. Here basically in this project, everything was grid connected and centralized also. So let's say if you want to go for the energy management system in the off-grid system, okay, or without grid connected system. So then basically we have to consider from the microgrid point of view. Okay. Then that is again very interesting point. And for then we need to develop the microgrid architecture in such a way, right? So considering the demand prediction, availability of resources, how we can shift or how we can use controllable loads for that. So in that scenario, basically then we can make it more like small microgrid, and then a microgrid central controller can provide the demand side management scenarios, right, to the controllable load also.
Any other queries from the participants? I think Nitish sir was trying to ask. Nitish sir, is it audible? You may ask your queries. There are no more questions.
So overall, I mean, still no more question, that's fine. So it means like everyone is in a position to understand, right?
You've explained in so simpler way, sir.
Yeah.
Okay.
So overall, I mean, are you able to understand at the high level, let's say, how such type of project is going to work, and how we have to integrate different technologies together, different domain knowledge together also, okay? And maybe learning from this lecture is that, like, how, if I know that most of you may be lecturers or professors, like, and having the teaching responsibility, so you have to see that how such type of projects or such type of things can be incorporated in your teaching while providing inputs to the students, right? How we can enhance the learning of the students by giving some examples of such type of projects also.
Definitely.
That also we need to consider, right? Not only going to use the textbooks and providing some numerical examples and like that. Of course, those are very important also to create the basic understanding or the basic knowledge. But again, on top of that, we have to see from the practical point of view, from the society point of view also, right? So how, I mean, while in our teaching, right, how we can incorporate, right, the learning from some of your lectures from FDP, let's say, for example, in your teaching. So that will help you not only for your personal development also, but it will also help us in developing the next generation also, or the student development also.
Definitely. I think there are no more queries in the chat box also. I must conclude now. So I, on behalf of the entire fraternity and the organizing team, extend a very hearty vote of thanks to our eminent guest, Professor Dr. Mohan Kole sir, for gracing your important work and sharing with us your findings and opinions today. I must mention my deep sense of appreciation for his explanation of UIA's global major smart grid projects, that is scalable energy management infrastructure for aggregation of household, SEMA, smart grid challenge, expertise of different project partners, key objectives of projects, SEMA aggregator framework, the SEMA system, SEMA front-end and back-end integration. Really, sir, it's a very insightful and interactive session we have. We are all inspired by your great words. The ideas of your project will definitely fruitful in our academic as well as research work. Thank you, sir, for sharing your expertise with us. There's request for tomorrow's session. We have our next session on 18 September at 10 a.m. So you are all requested to join by 9:50 a.m. before 10 minutes of commencement of session. For tomorrow's session, eminent speaker, Professor Manjari Pandit ma'am will join us, and she will share her experiences and expert opinion. Thank you all for a kind attention. Have a great day ahead.
Thank you very much, sir, for delivering very nice lecture, and I am thankful for enlightening us and giving the precious time.
I hope you enjoyed, right?
Thank you, sir. Thank you very much.
Thank you, sir. Thank you all.
Thank you, sir. Link for attendance is provided in the chat box. Kindly mark your attendance.